So guys, welcome back to my YouTube channel. So in this video, we are going to solve an interesting lead code problem, that is minimum number of arrows to burst a balloon. So the problem number is 452 and it is a medium level lead code problem. It's a medium level lead code problem. Level code problem. It is also the part of lead code 150. Lead code 150 and comes under the topic of intervals, where it consists 4 problems. Okay. So in this video, we are going to see the description part of this problem, that what the problem statement is trying to tell us. And in the upcoming videos, we will solve it out and see the approaches that are required in order to solve this problem. Okay, so without further wasting our time, let's quickly start understanding this problem. Okay, so as the problem statement is telling that there are some spherical balloons taped onto a flat wall that represent the xy plane. The balloons are represented as a 2D integer array where points at I is equal to x start x end denotes a balloon whose horizontal diameter stretches between x start and x end. You do not know the exact y coordinates of the balloon. Okay, so universally we know that this is the y axis, this is the x axis, and the region that is enclosed in this between these two axes is the xy plane, as we call it. Okay, so uh, in this region, in this xy plane, the balloons are basically taped. Okay, taped to the wall. Okay, now we have created an array, a 2D array named as points that represent the starting and ending point of these balloons. So we can take the example. Suppose the first balloon that we can see is, so the starting point will be 0 and the ending point will be 2, and in between this balloon is enclosed. Okay, and what else has been told in this thing, that we do not know the exact y coordinates of this balloon. So if we do not know, then we need not to know in order to solve this problem. So we will leave that thing. Okay, so this is what it is been told in this problem statement. We will read further that arrows can be shot up directly in positive y directions from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x, where x start is less than equal to x, greater than equal to x end. Okay, there's no limit to the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons in its path. So what it is trying to tell us now, that we can shoot this particular arrow, this this marked arrow, we can call that, in vertical y direction. Okay, and we can traverse along the x direction. So basically we can shoot this thing from traveling in the x direction from any of these particular points. Now we can shoot this arrow in the horizontal upward direction. This is what the problem statement is trying to tell us, and it will burst a balloon which come in its way. So suppose this arrow is at 0 and the starting point of this balloon is also 0. So if we will shoot this thing, it will get bursted, or anywhere in between the starting and the end point. So if we will shoot at 1, it will get bursted. If we will shoot at 2, it will get bursted. And now not only this, and if there are multiple balloons that are being placed in on the way of this, in the way of this arrow, they all will get bursted. So, and it has also been told that this arrow travels infinitely, bursting all the balloons in its path. So, and what we need to find in this particular question is that the minimum number of arrows required to burst the balloon. Okay, so So if we will think about this problem, we will have an intuition that we should shoot this arrow at a point which has intersection of maximum number of balloons in its way. So suppose if we take this arrow, wait a second. Okay, if we take this arrow and shoot this at point number 2, so it will cover all the 3 balloons. You can see that this balloon is getting covered, this balloon is getting covered, as well as this balloon is getting covered. So in one arrow we are busting 3 balloons. It's a really good deal basically. Okay, so we are going to uh, means take a variable like the count variable, we can tell count, and we are going to increase it to 1 since we have shot one arrow. Now we will again move. So these 3 balloons have been bursted. So we will again take this arrow and move to, I think, this point, because it is covering again the 2 balloons. Okay, so it will burst this thing also. So we will increase it to 2, and we will increase it to 2. So at max 2 balloons will be required. Minimum number of balloons required will be 2 in order to burst all these 5 balloons. I hope you're understanding the logic, uh, the problem statement, that what it is trying to tell us. Now in the upcoming videos, we will solve this thing and see the approach required.